Hi, this is week 7 of our chemistry class, and today we're going to go ahead and move on to unit number 2, which deals with material science. Today's lesson we're going to focus on the following topics. We're going to talk about the modern periodic table and compare it to the original periodic table by Dmitri Mendeleev. We're also going to go ahead and talk about the characteristics between a metal, a non-metal, and a metalloid. And finally, we're going to go ahead and learn how to calculate the average atomic mass, which is found also in the periodic table. Alright, so let's go ahead and get started. Our lesson objective. The objective of this lesson is to introduce students to the modern periodic table and compare it versus the original periodic table from Dmitri Mendeleev. Also, our objective is to know the similarities and differences between metals, nonmetals, and metalloids. And finally, students will be able to solve for the average atomic mass for elements in the periodic table. Let's get started. We're going to begin with the modern periodic table that we use today versus Mendeleev's periodic table. Dmitri Mendeleev was a Russian scientist who first put the elements together into the periodic table. He is known as the father of the periodic table. Element number 101, Mendeleevium, is named in his honor. Now this is his periodic table. And in his periodic table, what he did was he began to align elements into groups. And what he did is he grouped together elements that had similar properties. So for example, all of the elements in the first group, this first column right here, when exposed to water, they react very exothermic. It's a very exothermic reaction. It means they release a lot of heat, fire. It's possible. So they all have very similar behaviors. And so he continued. And what he noticed is that as he went along the way, the next one would go ahead and he would line it up here, will have similar properties. So it's very repetitive, which is periodic is another word for repetitive. And moreover, he had some challenges putting his periodic table together. The main challenge he had was that he only had about half of the elements that we now know. So he wasn't working with all the elements. On top of that, some of the data he was working with was good, but not 100% accurate. So he made some mistakes along the way based on his data not being 100% accurate. So as he went on, though, he made predictions. He made predictions that he felt that there was gaps in his periodic table. He figured out that, you know what, I don't have all the elements that this periodic table should have, and he left gaps. So all of these gaps you see here and there, those are elements that he predicted existed but had not been discovered yet. Not only did he predict that there were other elements that had not been discovered, he also made predictions about how those elements would look, how they would react to water, to electricity, and he wrote them down, what would be their approximate density. So he made a lot of predictions about these elements that had not been discovered. The way he figured that out is that, well, if all of these elements react with water, and until you get an explosive exothermic reaction, then this element over here that has not been discovered, when it reacts with water, well, it's probably going to do the same thing. So if these elements can conduct electricity, all of these, then these gaps right here, those elements could probably also conduct electricity. So if they behave the same way, he grouped them together. When he showed his periodic table to the scientific community, people really weren't that impressed by it, truthfully. It wasn't until later on, years went by, that new elements were discovered. And when these new elements were discovered, they realized that this new element matched perfectly the description that Mendeleev had said about this element before it was discovered. And that happened over and over and over. And that is when Mendeleev began to get a lot of recognition for his work with the periodic table. Now let's get into the modern periodic table. The modern periodic table is arranged by the element's atomic number, which is the number of protons. If we go back to Mendeleev's, you will not see any protons. All of these are weight. Mendeleev's periodic table arranged his periodic table by the weight of the element, how heavy it is. The new periodic table is arranged by the number of protons for each atom. So that is a very different arrangement. Alright, so Mendeleev's was arranged by the mass. Modern ones are arranged by the number of protons, atomic number. Alright, so that made a couple of elements be out of order in Mendeleev's periodic table. But that's one key distinction between them. One similarity again is that, well, if all of these elements behave the same way, they're still grouped together. So that's still something that persists from Mendeleev's original periodic table. Now both periodic tables of elements have that if they're in the same column, they're going to behave very, very much the same way as the elements right on top or beneath them on the periodic table. Now, the columns on the periodic table, they're referred to as groups, and the rows on the periodic table, they're referred to as periods. So right here on your periodic table, you should go ahead and number it on the side 1 through 7. If you don't have your periodic table handy, pause the video, get it, and go ahead and number right through here 1 through 7, and those are the periods. So those are referred to as periods on the periodic table. Across the top there's 18 of them. Those are referred to as the groups, and there's 18 groups. So now on the test that you guys are going to get for this unit, you will be asked questions such as, can you figure out what the group and the period for a particular element? So let's go ahead and do these: calcium, aluminum, zirconium, and uranium. Alright, find the period and the group for all of these guys. So let's go back a slide. For calcium, let's start with that one. Calcium, what's the period? The period is number 4. And the answer for the group is number 2. So there's calcium right there. Alright, our next element was aluminum. So aluminum, you'll find it here. What's the period for it? The period would be period 3. The group will be group 13. Our next element was zirconium. And zirconium, you'll find it right here. It's number 40. What is the period? The period would be number 5. And the group would be number 4. Finally, our last element was uranium. Now uranium does not have a group or period. All of these elements at the bottom do not have a group or a period. So there's no answer for that one. Alright, so that's our first example, and those are the answers. So you'll put something like Na and Na in that spot. Next, let's go ahead and talk about metals, nonmetals, and metalloids. On the periodic table, this line right here divides the metals here on the left, the nonmetals over here, and the metalloids touching this line. Alright, let's talk about what are they. Well, metals are elements that can conduct electricity, and you'll find stuff like copper, iron, and other elements that you don't really think of as metals, but calcium and sodium as well. On this side of the periodic table, you'll find nonmetals right here in blue. Nonmetals are elements that do not conduct electricity, and if they're solid, they tend to be brittle. That means they break easily. Alright, and you'll find stuff like elements, oxygen, fluorine, which you use in toothpaste, sulfur, iodine, and so on. Now, in between the metals and the nonmetals are the metalloids here in this tan brown color. If you notice there, all the elements touching the line are metalloids, except for aluminum. Alright, what are those guys? Well, they're somewhere between metals and nonmetals. Alright, let's get more into detail for each one of those. Metals. Metals, they tend to have 3 or less electrons on the outside part of the atoms. They have more electrons inside, but on the outside they either have 1, 2, or 3. That's characteristic for a metal. They're very good conductors of heat and electricity. Copper, which is a metal, is used for electrical wires in the house. Metals tend to be malleable. Malleable means you can easily shape it. You can get a metal rod, and if you heat it, you can hammer it and turn it into a different shape, maybe perhaps a circle. And metals tend to be hard solids with shiny surfaces. If you polish it, most of them will shine. Non-metals are up next, and whatever we said for the metals is pretty much the opposite. Alright, for non-metals, they have 5 or more, 5, 6, 7, or 8 electrons on the outer part of the atom. They're really bad conductors of heat and electricity. In a power cable, the outside part is some type of rubber material that tends to be non-metal, so that electricity cannot, you can handle that power cable without worrying about being electrocuted. Alright, they're poor conductors of heat as well. If you've ever been cooking with a metal spoon, you'll know that it gets hot pretty quick, and usually people either use some type of plastic spoon or a wooden spoon for cooking. So they're poor conductors of heat, so therefore that spoon's not gonna, the handle will not get hot. Most tend to be gases, and if they are gases, most of them are noble gases. That means that they don't react. And if they're solids, they're brittle solid. That means that they'll break very easily. they have dull surfaces. Now in chemistry there's always exceptions. So for example, diamonds are very hard and they're also nonmetals and they're very shiny as well. Here I have a picture of a Goodyear blimp. What element do you use to get a blimp to fly? You use helium. Helium is great. Which gas would be better as far as creating lift? That'll be hydrogen. It's lighter, but it's flammable too, so that's not a good idea. So helium is non-flammable. Alright, now metalloids. Metalloids will give you something like somewhere between a metal and a non-metal. For example, computer chips are made of silicon, and silicon is a non-metal, a metalloid that can both conduct electricity, but it's very brittle like a non-metal, so it has properties of both. Alright, using the periodic table, again, you have a line going down. Everything in green over here on the left side, it's a metal, except for hydrogen. Everything in right is a non-metal, and in between them, those are your metalloids. So when they ask you sulfur, is it a solid? Is it a metal, non-metal, or a metalloid? Well, you say sulfur. Sulfur's right here where my finger's at. It's in blue, so therefore you say, well, that's a non-metal. Hydrogen, also, although it's on the left-hand side, it is in blue, so therefore it is also a non-metal as well. Chromium. Chromium is right here, number 24, and it's in the green section. That is a metal. Tellurium. Tellurium, you'll find number 52 right here. It's in tan color, so it's a metalloid, somewhere between a metal and a non-metal. Alright, up next, now we're going to switch gears. We're going to talk about how you find the average atomic mass. That's the number you see at the bottom of each element on the periodic table. That's how heavy each element is. And they don't just tell you the weight of one element. There's different isotopes, so they get the average, and that's what you see there. But it's not just a regular average, it's a weighted average. So we're going to discuss how you solve for that in a bit. Alright, so the atomic mass is calculated by using weighted average, as I mentioned. And the weighted average is the result of multiplying the mass of each element times its abundance. Abundance is what percent is made up by that element. Alright, so we're going to go ahead and solve some problems now. Alright, so this is example 3 on the average atomic mass. And in this example, they're going to ask you to solve for the average atomic mass of the element silver. Now, silver's got 2 isotopes. So the first isotope has a mass of 107 U, which is short for atomic mass unit, and 109 U. Now we're not just getting a basic average. 107 and 109, the average would be 108. But we're doing a weighted average. A weighted average takes into account the fact that there's more of the 107 than there is of the 109. 60% of all the atoms for silver in nature weigh 107, so we're going to take that into consideration. So it says find the average atomic mass of silver if 60% of the silver atoms occurring in nature have a mass of 107 U, and 40% of the atoms have a mass of 109 U, atomic mass units. Alright, so we're going to begin by multiplying the percent. So I'm going to put here percent. And I want it as a decimal. Now what's 60% as a decimal? 0.6. And what I do with it is I multiply it times the mass for that particular isotope. This isotope has a mass of 107, so I'm going to multiply it times 107U. Our other isotope has an abundance of 40%, so I'm going to put it as a decimal, that is 0.4. And has a mass of 109 U. Alright, at this point you use your calculator, you multiply them, and then to get the total we're just going to go ahead and add them together. So it is 107 multiplied times 0.6 gives me 64.2, and 109 times 0.4, 43.6 U. Then you add them up, and that is your average atomic mass, 107.8 U. That is what you would see on the periodic table for the average atomic mass, a weighted average. Again, a regular average between 107 and 109 would just be 108. Notice that this one's slightly closer to the 107 because there is more of the 107 than there is the 109. Alright, so that is our first example for average atomic mass. Alright, we're going to go ahead and take a look at a second example. And in this one, it's going to go ahead and have 3 isotopes. Alright, so find the average atomic mass of krypton if 5% has a mass of 77.9 U, 15 has a mass of 79.9 U, and 80% has a mass of 81.9 U. Alright, so let's go ahead and do that. So there's 3 isotopes in this one. It's going to require a little bit more work. Let's get the percent. 5%. 5% as a decimal is this 0.05. 0.05 has a mass of 77.9 U. Next one, 15%, as the decimal is 0.15, has a mass of 79.9. And finally, 80% as a decimal is just 0.8. And that has a mass of 81.9. So again, same thing. Now we have 3 isotopes, so therefore that's 3 lines. So we go ahead and we'll multiply 0.05 multiplied times 77.9. It is 3.895. Next one, 0.15 times 79.9 gives me 11.985. And finally, 0.8 times 81.90. 65.52. I'm going to add the 0 there just so it looks a little bit better. Add them all together to get the final answer. My answer is 81.4 U. That is the average atomic mass for krypton. Alright, next problem is number 5. And this is our last problem. And in this problem, they ask you guys very similar question. This time, they're just giving you slightly different percentages. Alright, so let's see. It says magnesium consists of 3 natural occurring isotopes. The percent abundance for each isotope is as follows. Magnesium 24 is 78%. Magnesium 25 is 10%. And magnesium 26 is 11.7%. The average atomic mass of the isotopes are 24.3. That's the average. If the abundance of 24.99 AMU, that's for number 25, and for 26 is 25.98, calculate the actual atomic mass of 24. Alright, so this is a challenging problem. Alright, so let's go ahead and get to work on it. So the percentages for magnesium 24 are first listed. So I'm going to write it down so I can keep them straight in my head. Magnesium 24, oops, put it on this side. Magnesium 24, it is 78.7, so I'm going to write 0.787, throw in the 0, that's the percent. For magnesium 25, it is 10.13, so 0.1013, that's a percent, that's a decimal. And magnesium 26, it is 0.1170. Alright, so that's what we've got. Next, they tell you as the average atomic mass of the 3 isotopes is 24.13. So when we solve, the final answer is that 24.31 AMU. Then they tell you if the atomic mass of magnesium 25 is 24.99, that's a U. And for magnesium 26 is 25.98. Then they want to know, what's this? Alright, that is all the information that's given to us. And this is what we're solving for right here. What is the mass of magnesium 24? Alright, so we're going to go ahead and start. In this problem, I want to go ahead and get these answers and try to figure out what this is, and that's going to give us that. Alright, so let's do this. I'm going to multiply here, and put the answers there. So the first one, it is 0.1013 multiplied times 24.99 gives me 2.531. I'm going to round it off to 4 digits. Going to have 4 digits, 4 digits. 0.117 times 25.98 gives me 3.039. Alright, so this number plus that one gives me 24.3. So how can I solve for what is that number right there? Well, I could get the 24.3 and subtract both of these numbers, and that should give me that. So it's going to be 24.31 minus 3.039 minus 2.531, and that gives me, this top number is 18.74. Great. Now that I have that top number, this number times some mystery number, which is what we're trying to solve for, gives me 18.24. How would I solve for that? Well, the answer for that would be a division. If I divide both sides by 0.78, then that will give me this answer. So if I were to rewrite it as a math problem like in your math class, picture you have this. Multiply times some number. Let's just call it letter A. Or how about Mg for magnesium? And that equals 18.74, which we got it from right there. In your math class, how would you solve for this? You would divide by 78 on both sides, 0.78. And that's going to give you your mass of magnesium, which is what we're solving for. What's this magnesium? So the answer would be 23.81 U. Alright, so that is problem number 5. A little bit more challenging than the others. Alright, that takes us to the end of this lesson, and thank you for watching.